Yes, sir.
Hello?
Sir, you're audible.
Hello, can you hear me?
Yes, sir, you're audible.
Yes, sir.
Yes, sir.
Hello?
Yes, sir, we can hear you.
Yeah, yeah. Earlier I was not audible.
So you
No,
were
you were
audible.
audible earlier also.
Hello?
Yes, sir, you were earlier audible.
Earlier also I was audible, no?
Yes, yes.
Okay, but nobody is responding.
No, sir, you were responding.
I, I was not able to hear. Okay, I'll show a video on casting, so that will make the process clear. This is a small animated film. Now this is for core. So we want a hollow, and on the both the sides, these are called as the supports. This is the support for the core, and this is your cavity. And this is the support for the core. Okay, these two are support for the core, and this core is going to give you a hollow in the casting. This was the hollow which was generated because of the core. Are you there, Mr. Martin? Martin D'Souza? Hello. Sandra, are you there?
Yes, sir.
Ah. This Martin D'Souza was there. I am not able to hear him now.
Sir, there's Peter D'Souza.
Acha, Peter. There is no Martin D'Souza. Okay,
No,
sorry.
sir.
Okay, Peter, can you speak for a minute on this video which was shown? And then I will show one more video. And then Sandra, you have to speak on that video for a minute.
Okay, sir.
Hmm. Yeah, please, Peter.
So first the wooden replica of the but it is of the finished product is made, but it is a bit larger than the final product to account for the chipping processes. So it has two parts. Then with the help of sand, the two parts of the mold are made. Then with the top part, the riser and the gates are also added so that the liquid molten metal can be poured into it, and the riser is there to account for uh, extra metal that is required that would rise up for the other side. Then after that, the sand is poured and compacted, and after which the wooden replicas are removed. Then they are joined together, and the molten metal is poured inside the mold, and the excess comes out through the riser. After the molten metal is solidified, the sand molds are broken, and also the core is put inside with the support to make a hollow cavity. And after that, after the molten metal has solidified, the sand is removed and the core is also taken out, and then the gates and the riser are cut out, and to obtain the material. Then it is further chipping process is carried out to obtain the final product.
Okay, good. Now I'll show one more video.
Sir, I have a doubt, sir. Hello, sir.
This is another product. So
Hello,
first
sir.
we are keeping the pattern, then sand, then it is ramming, that is for compacting. Then they are turned upside down. Then they are matched properly. This matching is important. And along this you will get a parting line. Along this you will get a parting. Whenever they are joining, so there you are going to get a parting line. Okay. And parting line will be visible. Okay. No matter how much high degree of discipline you follow. Now here there was no core. Molten metal, this is called as a ladle. Solidification, cooling is important for solidification. See, now it is, you may have doubt, like when you are removing the cope portion, that is from the top, why it remains down, the product. So the mold is designed in such a way that it remains in the lower half. The product remains in the lower half. So it is slightly made rough than the cope. So cope we give good degree of finish, whereas here we give little less finish so that it gets stuck. It remains at the drag portion, and then this has to be ejected either automatically or you can manually you can lift it. That was about sand casting.
Sir,
Yes, sir.
sir, I have a doubt, sir. Why doesn't the sand
Yes.
fall when we fill the
Just a minute.
sand?
Because the sand has been compacted and rammed properly, एकदम rigid करते हैं उसको, so that it doesn't fall. Otherwise, it will not be of any use, no.
Okay, sir.
It has to
Thank
be
you.
it has to be rigidly hold together, and that is the property of sand also. Rigidness is one of the you cannot use any sand. You cannot use any sand.
Understood, sir. Thank you.
Yeah, most welcome. What's your name?
Omkar.
Omkar. See, this is now forging. Hmm. This is forging. Forging means heating and then shaping it. You have to hit and shape. Now this portion is called as the die. So now this will take shape as per the die. Now this is open die forging, which is manual. There is a cold die forging also, where it is automatic. You don't have to keep on hammering. So manual forging, automatic forging, open die forging, closed die forging, upset forging. There are many types of forging. This is extrusion. This is a direct extrusion. Extrusion में there are two types. One is push, another is pull. Push extrusion and pull type extrusion. In push, material is pushed, and in pull, it is pulled. जो भी प्रोडक्ट रहेगा वो प्रोडक्ट का शेप रहेगा डाई में. Extrusion force depends upon the friction. And how much is the push required. And depending upon that, extrusion machines are designed. These are nothing but push type of extrusion. What we do it in the morning while we brush our teeth. We take a toothpaste and we push it. Extrusion, again there are types: hot extrusion and cold extrusion. In cold extrusion we get very good finish. Pressure, force depends upon billet material. Billet, this is called the billet. Billet means raw material. Cross sectional area, complexity, and many things. These are the factors on which the pressure or the force depends. Extrusion force, billet material, then cross section area, how complex the shape is, the length, the temperature, extrusion speed, whether you want fast or whether you want slow, and reduction to extrusion ratio, that is suppose from 20 millimeter to 5 millimeter. Okay, so that is 4 times. So that is what is your extrusion ratio is. So these are the factors. Of course, you don't have to study in this much detail, but if you are asked to explain the extrusion process, then you can definitely quote this, that extrusion force or pressure depends upon these many factors. So, I mean, you don't have to study this in detail. Like there is a relation, there are mathematical models between force and cross-section area, between force and speed, between force and reduction ratio. But that mathematical models, that design, you don't have. You don't have to study. Extrusion, it is not necessarily for the aluminum. This is the die shape. And you must have seen windows sections, door section, filing cabinet sections. Those are all extruded. These are the billets. Billets is nothing but the round bar which are bigger in diameter. This is for the furnace in which the preheating is done or heating is done. Temperature is around 900 degrees Celsius. This is automatic loading of the component. Now the billet is forced against the die. Now squeezing is done. Then the extrusion is cooled, which is in the hot condition. See, this is what is your extruded product is. This is, and no machining is required here. You can directly use it. So you get a good tolerances also in extrusion process. And then you have to cut as per the required length. Now this is the long extrusion which you have got. You may cut it into 1 meter or half a meter, whatever length you desire. This is some other profile of extrusion, L type. This process is nowadays it is automated because many accidents has taken place. Extrusions, they are hot, isn't it? And if they are not guided properly, then it will move anyhow like snake. And if somebody is standing around, it can kill also if it moves and if it hits the person. So that's why extrusions has to be guided properly. And it is advisable that nobody should be into the vicinity. Now this will go to the aging process. Aging is a heat treatment process. It is also called as the age hardening. This is just to increase the hardness of the component. To increase the hardness or to increase the strength. These are the dies and this is the shape, that is what you are going to get in an extrusion. This is the maintenance of the die. Regular maintenance of the die is required, that is cleaning, oiling, greasing. So this much complex profile you can get in extrusion. This is just a screw, ball screw. This is extruded piece. Some more videos I will show you. Dhire dhire.
Sir,
Yeah.
sir, how are extrusions made hollow?
Hollow extrusions. So hollow extrusions are made in push-pull type of process. Push-pull. So that also I will show you how the hollow extrusions are made. Basically now push. See now it can be made even in push also. Like you saw the die, isn't it? And you saw the extrusions also. The center portion was hollow, no? Okay,
Yes,
so
sir.
there the material is not extruded. So it depends upon the die also. So in the die, wherever there is a hollow, from there the material will be extruded. Understand, no? And
Yes, sir,
whenever
but
and wherever there is no hollow in the die, the nothing will happen to the material. You understood?
yes, sir, but at the center of the extrusion, it had a pattern, so a die cannot be at the center of the Means how could the die be supported there?
No, no. Just now you saw the die, isn't it? In the die, wherever there is a hollow portion cut in the die, so there only the material will be extruded. Rest of the rest of the places it will not be extruded. So that will be a solid. That will be what, a hollow portion, isn't it? No, and remaining
Yes, sir.
portion will be solid. That is what will be extruded in the die.
Yes, sir.
See, now this is hollow, isn't it? And this is what is cut in the die. ये जो दिख रहा है ना, this is what is cut in the die, this portion. So this much material will be extruded from the die. This much material. So how you will get this hollow? So this hollow you will get in the die itself, because of the die, because of the profiles in the die.
Sir,
Yes,
but
sir.
So die will be of this shape. Die will be of this shape.
sir,
Yeah.
but how can die of that shape be made? Because sir, the
See this.
middle part,
Yeah,
sir, it
this.
would be in air.
This is what the die shape is. See this. So this much portion will be extruded and this much portion will not be, no? So this will be hollow, no? Hello?
Yes, sir, but how, sir, it can be made in middle, sir, without connecting to the rest of the part? It can't. Hello, sir.
Yes, yes. Huh?
Sir, sir, we saw that the finished product had, sir, material in between, sir. So how that die can be made, sir, if it is in that way, sir? Means, sir, it should be in air for, sir, that type of extrusion.
Wherever in the die, no? Wherever in the die, wherever there is a hollow, no? In the die, that
Yes,
much
sir.
shape will be extruded, I say. And remaining portion will be automatically you will get hollow.
Okay, sir. Understood.
So we were here, isn't it? Factors for selecting pattern materials. Omkar, these are the different pattern
Yes,
materials.
sir.
Huh? Have you done this? Wood patterns, etc.? No, na?
No, sir. I'm seeing this for the first time.
Yeah. This has been taken, no? So wooden patterns are used if the number of castings is small and if the pattern size is long or large. These are the advantages. Now what we are discussing, these are the advantages of making wooden pattern. These are the advantages of making wooden pattern. These are the limitations. Okay. Then this is metal pattern. I think I have taken this. I will quickly go through this metal patterns. Now when metal patterns, when to go? When you have to go for large number of castings from the same pattern. These are the advantages of the metal pattern. It did not absorb the moisture. Hmm? Metal pattern is more stronger. Definitely its life is more. It has good resistance to abrasion. So in handling also, in monsoon also, it doesn't get spoiled. Limitations of the metal pattern is it is expensive. Then you have to do lot of machining, and then you need to use machines like milling machine, lathe machines. I mean, of good quality. Now for wood, there are woodworking machines also, but those are all very simple machines and economical machines. Whereas if you want to machine the metal, then those machines will be expensive. Then if you want to repair the metal pattern, then you have to go for welding, brazing. So it is not that easy. Whereas for the wooden pattern, it is simple, and you can make new pattern also, wooden pattern, because it is not expensive. But in case of metal, normally we don't go for new because it is expensive. So it is advisable that you try to repair the existing metal pattern itself. Try to repair the damaged metal pattern instead of going for new pattern. Then you have plastic patterns also. Most advantage of plastic pattern is it is easy to make, and it is resistance to chemical, resistance to abrasion, resistance to moisture, and it gives a good surface. But it cannot take the shock, and the strength is less. Then POP patterns, that is plaster of Paris, POP. What we do, what the material, what we use in our house. So POP advantages are it can be easily worked, like easy to machine. Then intricate shapes can be cast. POP patterns का compressive strength is good, but quantity POP will be one only. POP patterns का. Generally we use it for only one molding. You can, but normally it is used to produce very, if the castings are in small in quantity. Similarly, wax pattern are preferred if you need very high accuracy. Then we go for wax pattern. So we were here, shrinkage allowance, draft allowance, like last time I had told, that is how to consider the shrinkage allowance. How to consider the machining allowance. So shrinkage allowance will depend upon the machines, on the material to be cast. Like different material, they have different shrinkage. Then you have draft allowance, you have shake allowance. So all these allowances you have to add on the pattern. Okay, suppose if the product size is say 100, 200 by 100, only length and width, and if the shrinkage is 1%, then the 200, the pattern size will become 202 by 101. Then you have to also add machining allowance, 22 millimeter. Okay, so it will become 204 by 103. Then you also add draft allowance and shake allowance. So that will be given in the numerically, in case if the numerical is asked. Now these are the special casting processes like expandable mold casting process. So in this you have shell mold casting, investment casting, vacuum mold casting, then expanded polystyrene mold, then plaster mold and ceramic mold. Then you have permanent mold casting processes. So permanent mold casting means what? In earlier case, that is this here, the life of the mold is not high, whereas in permanent mold casting, the life of the mold is high. Like in die casting, centrifugal casting, permanent. That's why it is called as the The connectivity was lost. Can you hear me?
Yes, sir.
Yes, sir.
Yes, sir.
I think I am not presenting. So the life of the permanent mold is more. So what happens in expandable mold casting? The mold is destroyed. That's why it is called the expandable. Expandable means you are spending expenditure. So you will get only one casting in one mold. So the mold is destroyed. So the mold will give only one casting, and a new mold is required for each new casting. So the pattern which is made is generally of the polystyrene. So the life of the pattern is also one, and the molten metal is poured, and the polystyrene, which is plastic, which is the type of a plastic, that is our pen. पेन का मटेरियल पॉलीस्टाइरीन रहता है. So that polystyrene will melt. Now there are different ways of producing patterns also. So sometimes it's not necessary that pattern is always made by machining. Pattern can made by molding also, and that is what is called as the investment casting. So that also I will show you how the patterns are made by molding. So whenever you want more numbers of patterns, so that time you go for this. Now how this expandable mold casting process is. Now remember, you have this pattern. This pattern is already there. Remember, this pattern you have already made from polystyrene material. Maybe for polystyrene round bars. See, polystyrene plastic का round bars मिल जाते हैं. Nylon बोलो, Teflon बोलो, polystyrene बोलो. So you will get a round bar in the market from which you have turned this. Now this pattern also can be made by molding process. But now let us assume that we have this pattern ready. Okay, so now we have kept this pattern in a mold, and then sand is rammed, and now we are not removing this pattern. Okay, we are just pouring the molten metal, which is at higher temperature. And the molten metal, it is, the temperature is 900 1300 degrees Celsius, and whereas plastics, majority of the plastics will melt at 150 degrees Celsius. Now there is a provision for gas. As the polystyrene burns, there is a provision for gas to escape, and that is what is called the vent lines. So vent lines are the small lines which you can cut at the top, or you can cut at the sides also. And then on solidification, you will get a casting. This is very cheap, and you get a good surface finish, and it can be used for complex geometry. There are no runners, risers, gating, nothing, no parting lines. Then you have shell molding. Shell molding casting is a process to produce the shell. And this was developed and patented by Cronin in World War II. So first you have to prepare a metal match plate. You have to mix with resin and sand. Then you have to heat the pattern, invert the pattern. Then you will get a shell on the pattern. So that shell you have to heat it and bake it, and that process is called the curing. And then remove the investment. Investment मतलब जो pattern है, so that you get a shell. There are certain things like you have to insert the core, then you have to design the supports for the cores so that cores doesn't get deflected because of the pressure of the molten metal. Then you have to assemble the mold, then pour the metal, then you have to allow cooling, that is called as the solidification. Then you have to remove the casting. Then you need to clean and trim. Trimming means you have to cut the risers, gates, runners, etc. So this is what a cycle is. So you have a pattern here. So that pattern is kept on a board. Looking. Now the box and pattern is now inverted. A, B. Now this is what a shell you will get over the pattern, this shell. So depending upon the time and temperature, you can control the thickness of this shell. Depending upon the time and temperature. This is somewhat similar to your vacuum forming. Like in vacuum forming, you are using for thin and whereas this shell casting can be used for thick products. वैक्यूम फॉर्मिंग यू माइट हैव सीन जो प्लास्टिक का जो रैपर्स रहते हैं लाइक से सोप रखने के लिए या पेन्स सपोज इफ यू वांट टू पैक 6 पेन्स और इफ यू वांट टू पैक 6 टूथ ब्रशेस in one package, so that 6 brushes are packed in a plastics which has the shape of that toothbrush, and that particular plastic is vacuum formed, and you must be knowing how much is the thickness. उसका thickness काफ़ी कम रहता है, less than 0.1, so that is nothing but vacuum formed. लेकिन जो shell mold रहता है उसका thickness ज़्यादा रहता है. And then once it is solidified, once it is cured, then these ejector pins can be operated from the down, spring loaded, or you can push them. You can push the ejector pins so that the shell which is formed on this pattern can be ejected out. Now this is what a complete hollow shell complex of this size, and this is the parting line. This is what the parting line is, which will be visible. A shell molding का और एक example. That was one example. This is one more example. Like you have a pattern here, then you have a sand, Then this sand is being deposited on the pattern. The pattern is now called as the investment. That is pattern plus coated sand is called as an investment. Then you get a shell depending upon the time and temperature. Now this pattern and shell is removed from the box. So like that you can make two shells and then join together. Now this shell, a round shell, can be used as a pattern to make a hollow. See, now this shell is already produced by this molding process, and this shell is again used for producing a hollow thin walled component. Now you are putting a core inside this and you are putting sand from outside. Then you have to remove this shell and put a molten metal so that you will get a hollow thin walled pipe or thin walled product. Again same thing, this is a heated pattern. Then this is the sand with the resin binder. So this is made ulta, that is inverted, and since this is pattern is heated, it is in heated hot condition. Okay, it will stick. So depending upon the time and temperature, you will get the shell. Which you are removing. And then you are joining these two shells together, and now this shell forms a pattern for new mold. This is just an explanation for shell mold castings. Only disadvantage is that the metal pattern is expensive. You get a good surface finish, good dimension accuracy. It is suitable for mass production. Where it is used? It is used for steel casting, crankshaft, which is used in the engine. It is superior to, it is expensive, but it is better than sand casting process, and it is used for accurate products. Another important thing is that here in shell mold casting, you need a heated pattern, remember, heated pattern, and then you have to add some binders in the sand so that it will form the shell. So one was sand casting, another was shell mold casting, and third is investment casting. Investment casting is also called as the lost wax casting. Also called as the lost wax casting. Because here wax patterns are used, they are coated with the refractory materials, and that is what we call as the slurry. Investment casting is again used for very small intricate shapes. The process is slow, and these are the steps here. Like you have a wax pattern, you have made some wax pattern, and this wax patterns, they are attached to the wax sprue. Wax matlab mombatti. Okay, so now here these are the 4 patterns, okay, which are attached to the wax sprue. Now this is the slurry, ceramic slurry. ये जो है वो ceramic slurry है. Now these wax patterns, they are dipped inside this ceramic slurry for particular time. Now this ceramic slurry will get deposited on this wax pattern. इसके ऊपर ये ceramic slurry है वो deposit होएगा like shell mold casting. But here it is not sand, not resin, here it is ceramic slurry. Then हम लोग क्या करते हैं, step number 5. Then we are heating this. Now because of heating what will happen, ये जो wax है अंदर का वो पूरा मेल्ट होके निकल जाएगा. Okay, and then you will get a shell like this which is made out of ceramic. अभी इसमें हम लोग, now this is like mold. So how many molds you got here? You got 4 molds here, 4 molds. और अंदर का वैक्स किधर गया? वैक्स पैटर्न मेल्ट होके निकल गया. हाउ? बिकॉज वी आर हीटिंग इट. अभी ये हीट जब भी करते हैं तभी सिरेमिक कोटिंग है, that is temperature resistance. Okay, the ceramic will not melt, but अंदर का जो wax है that will melt. So you are getting now 4 molds here. Now in these 4 molds you are pouring molten metal. So this is your sprue, then you have runner, then you have gate. अभी ये जो molten metal है that will occupy this space, and then you will get on solidification you will get this product. So on solidification this will shrink inside. Okay, and if the product doesn't come out, then you have to break this ceramic so that you will get this product. And ceramics can be broken easily. So this is the procedure. Wax pattern बनाना है, patterns attach करना है, then उसको coating करना है sufficient refractory material. Now what is the refractory material here which we use? Ceramic slurry. then उसको उल्टा करने का है, then wax को melt करना है by applying heat so that wax runs away, and then you can pour the molten metal, allow it to solidification, then mold is broken and the part is removed. This is the procedure for your wax or investment casting. So now this is a mold for producing wax pattern. Remember, this is ये जो step A में दिखा है, that is a mold for producing wax pattern. So ये आपको wax pattern मिल जाता है. Okay. Then a wax pattern you are attaching. Then इसको dip जैसा कि हम लोग चाय का पत्ती डिप करते हैं, डिप वैसा ही हम लोग इसको डिप करते हैं एक ड्रम में जिसमें कि रिफ्रैक्टरी मटेरियल रहता है, यूजुअली सिरेमिक स्लरी उसको बोलते हैं, सो दैट इट गेट डिपॉजिटेड सिरेमिक स्लरी. देन हम लोग उसको गर्म करके अंदर का जो वैक्स है उसको निकाल देते हैं, वैक्स, सो दैट यू विल गेट हॉलो इनसाइड। तो ये आपका मोल्ड हो गया, 6 मोल्ड हो गया, एक 6 प्रोडक्ट आपको मिलेगा, 1 2 3 4 5 6। उसको और थोड़ा गर्म करते हैं सो दैट कड़क हो जाता है। देन आप मोल्टन मेटल यूज करते हैं, ठीक है। देन उसको जोर जोर से वाइब्रेट करते हैं। सो वाइब्रेट करने से क्या होता है, ये जो सिरेमिक है दैट इज ब्रिटल, बाहर का जो सिरेमिक जो है वो ब्रिटल रहते हैं, वो निकल के आ जाते हैं। ओके, सो दिस इज समवॉट सिमिलर टू योर शेल। हाँ, बट शेल में कैसा रहता है, एक ही बनाते हैं प्रोडक्ट। हियर यू कैन गेट मल्टीपल प्रोडक्ट्स। देयर द पैटर्न इज हीटेड, हियर द पैटर्न इज नॉट हीटेड। ओके, so this is the process step: produce a master pattern, produce a master die, produce wax pattern, assemble the wax pattern on screw, remove the wax, heat the mold, pour the molten metal, and then remove the solidify casting from the mold. This is one more example, like you have वैक्स का पैटर्न्स लगाया हुआ है, स्क्रू है, रनर है, गेट है, देन उसको हम लोग डिप करते हैं सिरेमिक स्लरी में, ड्रम में, ऊपर नीचे ऐसा दिखा है ना, डिप डिप डिप, सो दैट यू गेट अ कोटिंग ऑफ सिरेमिक स्लरी। देन वैक्स को निकाल देते हैं, देन मोल्टन मेटल डालते हैं, सो दैट यू गेट दिस फिनिश कास्टिंग। फिनिश कास्टिंग कैसा मिलेगा, उसको जोर जोर से वाइब्रेट करने का या तोड़ने का, सो दैट जो बाहर का जो सिरेमिक है दैट बीइंग ब्रिटल, that can be removed very easily. One more example: you have a wax pattern here, assemble किया, then coating किया ceramic का, this is also called as the shell preparation, somewhat similar to shell molding, but of course there is a difference. The procedure is, I mean the principle is same. Then dewaxing मतलब वो जो अंदर का जो वैक्स है उसको हीट करके निकाल दिया, देन थोड़ा हल्का सा गर्म करने का, तो ये जो सिरेमिक जो है वो थोड़ा हार्ड हो जाता है, देन पोर द मटेरियल, देन वाइब्रेट करने का, तो जो सिरेमिक कोटिंग है वो निकल जाता है। द एडवांटेज इज दैट यू गेट एक्सेलेंट एक्यूरेसी, गुड फिनिश। लार्ज क्वांटिटी होने दो, स्मॉल क्वांटिटी होने दो, फॉर बोथ इट इज फाइन। Disadvantage is limitation on the size of the casting, cost ज़्यादा रहता है, and it cannot be used for bigger castings. Mostly it is used in jewelry, dental implants, medicines, that is ear plugs, rocket components, but for the small components. Okay. So next class we will see these permanent mold castings. Yeah, any doubt? Okay, then enjoy your break, lunch break. Hello.
Thank you, sir.
Yeah, thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.